The cooling system in a car engine, almost all modern cars use a liquid-cooled system, prevents the engine from overheating by removing excess heat produced during combustion. An internal combustion engine converts only about 20 to 30% of fuel energy into useful power, the rest becomes heat. Without cooling, the engine would seize or suffer severe damage, like warped heads, blown gaskets, or cracked blocks within minutes. The system maintains the engine at an optimal operating temperature, typically 80 to 100 degrees Celsius, 176 to 212 degrees Fahrenheit, for best efficiency, lower emissions, reduced wear, and good heater performance. Main components. Here are the key parts of a typical automotive cooling system. Coolant antifreeze mixture, usually a 50-50 mix of water and ethylene glycol-based antifreeze. It absorbs heat, prevents freezing in winter, raises boiling point, and includes corrosion inhibitors. Water pump, a centrifugal pump, belt driven by the engine's crankshaft or serpentine belt, that circulates coolant through the system. Engine block and cylinder head passages, internal channels, water jackets, surround the cylinders, combustion chambers, and valves where heat is picked up by the coolant. Thermostat, a temperature-sensitive valve that stays closed when the engine is cold, to speed warm-up, and opens, usually around 85 to 95 degrees Celsius to allow full flow to the radiator. Radiator, a heat exchanger, usually aluminum with fins and tubes, at the front of the car. Hot coolant flows through it, and incoming air, from driving plus fan, removes the heat. Cooling fans, electric or engine-driven, pulls air through the radiator when the car is stationary or at low speeds. Hoses, rubber hoses connect everything, upper, lower radiator hoses, heater hoses, bypass. Expansion overflow tank, catches excess coolant when hot, system is pressurized, and returns it when cooling, prevents air pockets. Radiator cap, pressure cap, maintains system pressure, typically 0.9-1.1 bars, 13 to 16 psi, raising the boiling point of coolant to approximately 120 degrees C+. Heater core, a small radiator inside the cabin, hot coolant flows through it to provide cabin heat. How it works: coolant flow. Cold start, thermostat is closed. Coolant circulates only in a small loop inside the engine, by a bypass, warming up quickly. Engine warms up, thermostat opens right pointing arrow, hot coolant flows to the radiator. Heat absorption, coolant picks up heat from the engine block head. Cooling, hot coolant enters the radiator, top, flows through tubes, fins, loses heat to airflow, right pointing arrow exits cooler at the bottom. Return, cooled coolant returns to the water pump, right pointing arrow back to the engine. Cabin heat, some coolant is diverted through the heater core, fan blows air over it for warm cabin air. Pressure management, expansion tank handles volume changes, pressure cap prevents boiling. The cycle repeats continuously while the engine runs.